Good day, everybody. My name is Alexey Zhukov. I'm professor at High School of Physics, Mathematics and Computer Science here in St. Petersburg branch of the Russian Academy of Science. My specialty is semiconductor physics. Mostly my field of interest in laser physics, quantum dots, and something around this. When I was young, I joined the YOF Institute, Physical and Technical YOF Institute here, to the laboratory of academician Alfyorov, so very famous Russian scientist. Soon he became a Nobel Prize laureate. And once we start to study quantum dots. I mentioned quantum dots. So, and me and my colleagues, a group of my older colleagues, we present the first in the world quantum dot lasers. It was maybe the greatest success in my scientific life. Here in High School of Economics, we organize a laboratory. Name of the laboratory is International Laboratory of Quantum Electronics. I am an academic supervisor of this laboratory, and here in the lab we're doing experiments with semiconductor materials, with nanostructures, for example, to study their optical properties, to study some effects associated with their dimensionality, with for example, quantum size effects. Also, we are thinking about new devices, new material properties which are important for these devices. So we doing experiments with, for example, with lasers, with optical communication, and so on. I believe that what we do, our research, will find some real application, and it will be very great award and honor for me. Here in Russia, the YOF Institute of the Russian Academy of Science, it's located here in St. Petersburg, and it's maybe the largest institute in the field of physics, and we cooperate with it for epitaxial growth, for post-growth processing. Also, we have partners in Moscow, many other cities. I have to mention South Federal University, where we initiate a joint mirror laboratory project, something like this, if my translation is correct. Also, we have partners in China, in Germany, in the United States, it's in many different countries. So, because semiconductor physics and lasers are very hot topics everywhere. everywhere. Doing experiment, doing some experimental work with semiconductors, with light-emitting devices, when electrons and holes are recombine and produce light. It's very interesting. It's difficult to imagine how it's really do in the nano world, but when we do experiments, we can get some response from the very small materials, and if this response corresponds to our predictions, it's like the best awards for the scientists. Everything like it should be. They provide building room for laboratory. They provide conditions for colleagues. We can attract researchers to work with this equipment. They provide everyday help with students. We establish very nice laboratory. We establish very tight cooperation with other organizations, with scientific partners, and we feel support from the leadership of the university, and there is a plans to increase our laboratory capability and increase the staff of the laboratory and the physical department as a whole. So I hope that quite soon we will be stronger compared to our present our present life.